So the next part of the discussion, the next chapter under our discussion is carbon and its compounds. It's also called chemistry of carbon, compounds. That means indirectly here we are just speaking something about the carbon chemistry. If you take carbon symbol is C, its atomic number is 6, atomic mass represented by A 12, and if you go to the structure of the carbon atom, nucleus, it contains 2 shells. In 2 shells we have 2 electrons in the first shell and 4 electrons in the valency shell, and it has 6 protons in the nucleus. And moreover, carbon is this is the composition of atom, that is atomic number of carbon is 6 and atomic weight of carbon is 12, and here we can take this carbon, it's a non-metal actually. Carbon is a non-metal and it belongs to P block of the periodic table. Fine. If you go to the structure of electronic structure of the carbon, that is atomic structure of carbon, here you are finding that it contains 4 valence electrons, it contains 2 core electrons, it contains a nucleus, and it contains 6 protons. So from this it's very clear that from this structure of atomic structure of carbon, it contains total 4 valence electrons, 4 electrons which are valence electrons. It contains 6 protons. So if that is the case, this carbon, if you take if it wants to lose all these 4 electrons, if you want to remove 4 electrons from the carbon, 2 electrons and 4 electrons, you need large amount of energy. You need almost 4 ionization energies. Ionization energy 1, 2, ionization energy 4. If you apply, then only this carbon can acquire 4 units of positive charge with the loss of 4 electrons. But that is quite difficult, because when you, until and unless you supply large amount of energy to remove all the four valence electrons present in the carbon cannot lose all the 4 electrons and it cannot form 4 positive charges. That means with great difficulty, what exactly we have to understand here is, carbon with great difficulty it is going to acquire 4 units of positive charge. So therefore carbon cannot show the positive oxidation state plus 4 oxidation state with that much easiness. Similarly, if you go for the same carbon, there is one more difficulty for the carbon. If you take carbon 2 electrons and 4 electrons, at the same time carbon also, it cannot gain all 4 electrons at a time to acquire C4 minus, because the problem is here, if the carbon is going to gain another 4 electrons, total 6 electrons are already there in the C4 minus. In the C4 minus, the composition, if you take, it has 6 protons, and now it has total number of electrons 4 electrons plus 4 electrons, total 2 electrons plus 2 electrons and another 8 electrons, total it has 10 electrons. 6 electrons, it becomes very difficult. 6 electrons cannot be attracted so easily. The 6 protons cannot attract 10 electrons so easily in the structure of the atom within the nucleus. So with great difficulty the carbon is going to form C4 minus, that is carbon cannot acquire 4 minus oxygen state or negative oxygen state with that much ease. Now this is something about the electronic structure of carbon and the electronic property of the carbon. And if you go to the general introduction of the carbon, now why this chapter we call it as carbon chemistry, why carbon is so unique? As already I told you, let us put it in this way, let us understand the carbon property of carbon in this way. Carbon as an element is always unique. It has unique properties. One is carbon is non-metal. Carbon is non-metal, first point. Second point, carbon can react. It can react with any element. It can react with metal. It can react with non-metal. It can react with even a metalloid. It can react with even metalloid. This carbon, it is a source of living and non-living components. Non-living components. If you go for a living source, if you take the living source, for example, living source, plants, animals. These plants and animals in turn, they produce certain energy sources like carbohydrates, proteins, amino acids, and so on. If you go for non-living components, if you take the carbon as non-living, you can take wood, plastic, paper, minerals, oxides, many more, so on and so forth. Last but not the least, this carbon is also having one more unique property. That one more unique property which we can take here is that it has catenation power. Carbon has a unique property called catenation power. What do you mean by catenation power? The interlinking of the atoms either in straight chains or branched chains in three-dimensional pattern. The interlinking of atoms either in straight chains or in branched chains in three-dimensional pattern, we simply call it as catenation power. The catenation power is very strong in the case of carbon when compared to all other elements in the periodic table. That's the reason the carbon is studied. That's the reason this carbon